Okay, we want to find the domain of this rational function. Again, rational just means it's a ratio, or basically a fraction, right? I've got a ratio of two polynomials, 9 compared to x squared minus 4. That's all rational function is. Now this denominator is the key. It cannot equal 0. So if we want to find the domain of a rational function, I would try to simplify first, but nothing here will simplify. So just set that denominator equal to 0, and now we're going to solve it. And there's different ways you could do that. This will factor. You could add the 4 over and just square root both sides. I'll just go ahead and factor it here. So x plus 2 times x minus 2 equals 0. Now of course I could set each of these little pieces equal to 0. So x could be negative 2 or positive 2. Those would make this true. Well, why did we just do that? Excuse me. Why did we just do that? Well, we want to know what would make this 0 because x cannot be that. So in this case, the domain is things that we want to know what it can't be, because then it could be anything else. So on a number line, let's just visualize that. So negative 2 and 2, it cannot be that value. It cannot be that value, but it could be everything to the left. It could be everything in between, and it could be everything to the right. Kind of think about our interval notation, right, in our last lesson. So let's put that in interval notation. Really want to practice that and feel good about it. So this would be negative infinity up to negative 2 union. Then we've got this middle stuff, negative 2 to 2. And then we've got one more interval. So this one's got 3 intervals. 2 to positive infinity. So that is the domain of that rational function. Well, what would that graph look like? I'd encourage you, pull out your calculator. I'm going to graph it here with you. So let's go to our graph, and I'm going to enter this function in. So we've got 9 over x squared minus 4. Let's go see what that looks like. So here it's coming from the left, shoots upward. Then interesting, we've got a middle piece, and then it comes down. So notice it's not continuous. These aren't connected. And here at negative 2, there's kind of an invisible line there, an invisible barrier. We call that an asymptote. We're going to talk more about that in the future. Over here at positive 2, there's also an invisible barrier, an asymptote. And so if I went in here, trace, and I typed in a value, negative 2, it doesn't give me a value. That's because it doesn't exist. If I type in something like 5, oh, it'll tell me what the y value is. Positive 2, again, there's no value there because it's undefined. So interesting, that's what the graph looks like. So key to a rational function, set that denominator equal to 0, solve it. That's what x cannot be.